Okay, so we will learn to animate a graph or a curve in MATLAB. We'll animate this graph. Here is its corresponding equation. Now this graph shows the position of some particle which is moving linearly as time progresses. So let's switch over to MATLAB. Okay, so here in MATLAB, let's create a new script. You can clear all and CLC as well. Now for our equation, which represents the position of the particle, we have 6, which is multiplying the time Okay, so this is what we have for the position, and then for time we will start from 0 to 6 seconds, just like that. Okay, so let's use linspace. So let's start from 0 and at 6 seconds let's do 12 divisions. Okay, and then what can we do? Let's plot this to have a look. We can plot this. I'll save it with the name position curve, and then run it. Alright, so this is the curve, but it's not smooth enough. So what I'm going to do is I'll increase the number of data points from 12 to 60 and rerun this. Have another look. Okay, now our curve is smoother. Okay, so what I want to do next is I want to animate this. Okay, so I'll use a for loop. So I'll say for every data point in 1 to the length of t, I will plot t and x. Okay, but in this case what I want to do is I want to plot each data point. So I'll take the first iteration of time and position, and I'll plot that. Okay, so let me run this and see what I have. So I virtually have nothing. Let me include a marker. Let's say use plus as a marker. Run this once more and see, now I have this, but it appears there is nothing happening. So what can I do? Let me include a pause statement. So I would say that after each data point, so after the first iteration, pause for, let's say, 0.2 seconds, and then move on to the next point. You run this. Okay, and this is what I have. So I start from the first iteration and then I move all along each iteration until I get to the 60th iteration. So that is what I have. Okay, now you see that the motion is randomized. It's all over the place. So what I can do is I can fix the axis. So for the axis in the x direction, at 6 seconds the position you get is at the 6th second we are 0. Now at the 4th second the maximum distance is 32. So for the axis in Y, I'll use 0 to 32, and for the axis in X, I'll use 0 to 6. So let me fix my axis by supplying a row vector. So for the x-axis, I'll say 0 to 6, and then 0 to 32 for the y-axis. Let's put the axis right after the plot. Now let me run this again. And now I have the motion, so I take flight from here all the way to the maximum, and then I descend to 6. Okay, so this is how you achieve that animation. But apart from this animation, I also want to see the line or the curve itself being drawn. Okay, so for me to do that, all I need to do is to plot another curve. So I can use this statement right here. So I can copy and paste it. But before I do so, I have to hold on to the previous graph or to the previous curve. Okay, and now I can plot t and then t and then x of I. Now, one thing we need to consider is that whenever I plot the curve, for instance, if I am on the second iteration, then I'll have to plot the curve. If I am on the second iteration, I have to plot the curve from the first iteration. If I am on the third iteration, I have to plot from the first iteration so that I can have continuity. So because of that, I'll plot from the beginning to I, right? I have to start from the very first data point all the way to the current iteration. I have to start from the first data point all the way to the current iteration. So let's run that. Okay, and then this is what happens. Alright, so this is how you go about that.